Okay, so we're doing a new problem, section 5.5. We are going to this time do a definite integral. We are doing a definite integral. So if you remember from Calculus 1, what is a definite integral? Okay, well that's one where you have actual limits, a bottom limit of 0 in this case, and a top limit of 5. And if you were to graph the function x divided by the square root of 1 plus 3x, if you were to graph that function and try and then say, well, I want to find out the area between that function and the x-axis from x equals 0 to x equals 5, that area would be the value of the integral. And remember, area can be positive, it can be negative. The integral is the net area, the net total area. So, okay, we look at this, and again, as always, this is not a problem that we're going to know the antiderivative of offhand. So we have to make a substitution. Okay. We're going to let u equal, all right, so, what do your instincts tell you? What would be a good substitution here?
1 plus 3x.
Definitely, Tosh, Brian and D'Angelo, 1 plus 3x. I mean, we're going to try it. So, okay, well, let's go to the solution here. Let's look at how the solution works out. So u equals, that's right, Sandia, u equals 1 plus 3x. Very good. And so now, this part here, the square root of 1 plus 3x, becomes the square root of u. Okay, well, what's left then is the x and the dx, but also the limits have to get changed because these limits are x limits. We're going to need u limits. Okay, let's focus first on the x dx. So as usual, since u equals 1 plus 3x, I'm going to differentiate du with respect to x. That gets me du dx equals 3. Okay, but that means then that du is 3 dx. Okay, well, dx then would just equal 1/3 du. So the dx is 1/3 du. So that takes care of the dx. But now we have to still find out what x is going to be, right? Well, this problem, look at what we can do. Because u equals 1 plus 3x, that means then that u minus 1 is 3x. And so u minus 1 divided by 3 equals x. Okay, so then x, we can replace x with u minus 1 divided by 3. Okay, and our integral then becomes this integral here with respect to u. But there's an added thing that we have to do here. The limits have to be changed also, because in this integral here, this integral is an integral with respect to u. So the x limits have to be converted to u limits. Well, the first x limit was x equals 0. Well, since u is 1 plus 3 times x, the bottom u limit is going to be 1 plus 3 times 0, which is 1. The top x limit is 5. Well, 1 plus 3 times 5 is equal to 16. So those are our new u limits. And then, of course, the remainder part of the integral, the other part is we replace the x with u minus 1 over 3. And we replace, of course, the square root of 1 plus 3x with square root of u. And then the dx is 1/3 du. Are there any questions up to here? Up to that part? All right. Well, so what I want to do, I generally like to bring constants out in front of the integral because they can be kind of a nuisance. So u minus 1 over 3 here, u minus 1 over 3 is the same as 1/3 times u minus 1. So I have a third here. I have a third here. I'll bring both of them out in front of the integral. So that's 1/3 times a third. And so what I'm left with then is u minus 1 over the square root of u. Naturally, what we have to do is rewrite u minus 1 over the square root of u. We have to rewrite that. Well, we'll remember that u minus 1 over the square root of u, that can be written as u over square root of u minus 1 over square root of u. Okay, I mean, it's no different than saying like, 7 minus 1 over 5 is equal to 7/5 minus 1/5. It's no different. So I'm going to be taking this integrand, u minus 1 over square root of u, and rewriting it this way. And you're going to see that's very helpful. I'll show this on the next page. Are there any questions before we move to the next page? All right. All right. Well, then let's go ahead and proceed forward here. So here now
Oh, can you go back, please?
yes, yes. All right. So I do try to get our lectures done by 5:10 because that's the official end time. Occasionally I might go over a few minutes, but we might go over a few minutes, but it won't be long class, okay? It's always a balance. I want to try to answer questions, but then of course it takes a little more time. That's okay. Sandia, you're good? Well, I erased it. But let me tell you, let me go, hold on. Let me go here. What we had here, we had u minus 1 over the square root of u. And I just then, now I write that. This is what I had in red, I believe. This is now equal to u over root u minus 1 over root u. But, okay, now clearly we have to, this has to be worked on a little bit. So u over root u, okay, is the same as u over u to the half power. And 1 over root u is 1 over u to the half power. But u over u to the half power is the same as u to the first power over u to the half power. And I know that when you divide, you subtract the exponents. So that gives me u to the 1 minus a half power, which is u to the half power. And then 1 over u to the half power is u to the negative half power. And that's what we have right here. And now it's just a calculus 1 problem. We need to find the antiderivatives of u to the half power and u to the negative half power. And the antiderivative of u to the half power is 2/3 times u to the 3/2 power. The antiderivative of u to the negative half power is 2 times u to the half power. Now that we have the antiderivative, we substitute in our limits. We know from calculus 1 that the 16 limit is going to go in the antiderivative first. Okay, and so you're going to have 2/3 times 16 to the 3/2 power minus 2 times 16 to the half power. And then from there, we're gonna put the 1 in for the u. Okay, and so we're going to be subtracting 2/3 times 1 to the 3/2 power minus 2 times 1 to the half power. And what I did was I just used like basic, your basic math. 16 to the 3/2, 16 to the 3/2 is equal to 64, because that's like 16 to the 1/2 power raised to the 3rd power, which is 4 to the 3rd power. That's 64. I just used fundamental principles. But this step here, what we find, like doing in Desmos, you'll get 108 over 3. And so the integral, the area between hold on, one moment. Yeah, the area between the function, that rational function, which is x over the square root of 1 plus 3x, the area between that rational function and the x-axis, the net area, is 1/9 times 108/3. Now on the next page, I'll multiply that out and get a final fractional answer. But are there any questions here? We're almost done, class, almost done. All right, very good. Well then, let me go ahead to the next page. The answer, when you take 1/9 times 108/3, the answer is going to equal 4. So that is the answer. And so now you've seen today 3 substitution problems, and hopefully you have a decent feel for substitution, but naturally it takes practice. Generally, you want your substitution to be a reasonably easy substitution. That'll help you break out the integral. Are there any questions? Yes, let me go back here. Sandia. Okay, you're welcome. All right, are there any other questions before I stop the recording? Okay, I'll stop the recording.